there, folks. This is Dr. Bower-Phipps here. I'm going to show you how you can work through this lab, either together or with your lab partner. We're going to be modeling chemical formulas and using the periodic table. Are you ready? Here we go. Okay, so the first part of this lab is modeling compounds, right? We're going to use colored dots to represent atoms, and we're going to use the formula to figure out how many of each atom you need. And then I'm going to ask you to do a key based on the color atom you used for each element. So what that means is, first up, we have the formula KBr, right? So that means that I can use a different color for each different atom. And I gave you lots of colors to choose from. It doesn't matter to me what colors you choose for any of these. So K, potassium atoms, I'm going to have as red. Br atoms, I'm going to have as yellow. And in this formula, it tells us, because there are no little numbers, no subscripts, it means that there's one potassium and one bromine, and they are touching each other, right? There's a chemical bond. So I'm going to show those two as touching each other. This is KBr, 1K, 1Br. Pretty simple, right? Let's try another one. H2O. This time I'm going to have H represented as orange. I'm going to have blue represented as the oxygens. The 2 next to the H tells us there are 2 hydrogens. So I need 2 hydrogens there. And blue, there's 1 oxygen. So I have 1 blue oxygen there. It doesn't matter to me how you connect them, but they need to be connected. So you can show them like this, next to each other like that. You can show it as one in the middle. You can show them any way you want, as long as you have 2 of the hydrogen ones, right? Hydrogen I'm representing as orange, and blue, 1 blue oxygen atom, right? 2 H's, 1 O, and they're all connected to each other because it's a compound. So far, so good. Let's try another example. Now we have KCN2, potassium cyanide. Oops, this formula is wrong. Just kidding. I'm going to change this formula right now because the formula is wrong. Calcium cyanide. Now I need 2 cyanides for every calcium. Well, it doesn't matter why. Okay, this is new because now we have parentheses, right? So you're bringing in your math skills. The parentheses surround the C and the N. The little 2 outside tells us there are 2 CNs, 2 each. It distributes 2 Cs, 2 Ns. So I'm going to have calcium be the red ones. I'm going to have C carbons be yellow, and I'm going to have nitrogen be blue. This formula tells us that there's 1 Ca, and now inside these parentheses there are 2 Cs and 2 Ns. So I need 2 Cs and 2 Ns. Again, I don't care how they're connected to each other. You can show them all in a straight line. You can show them in a triangle. You can show them grouped together. I don't care how they're connected to each other, but you need 1 Ca, 2 Cs, right? 2 times 1 carbon, and 2 nitrogens, 2 times 1 nitrogen. All right, it distributes through. Let's try one more, a little bit harder. Now we have CaHCO3, and now inside these parentheses, right, we have 3 different things. It's a little bit harder, and there's a 2 outside. That 2 distributes to all of them. So I'm going to have red be calcium, hydrogen be orange, carbon be yellow, and I haven't used purple yet, so I'm going to use purple for the oxygen, right? Different color for each different element. Now in my formula, I have just 1 Ca. The 2 only goes to the things that are in the parentheses. It doesn't go to the calcium because it's outside. So I need 1 Ca. There's only 1 hydrogen inside the parentheses. So 1 times 2, I need 2 hydrogens. Hydrogens are orange, so I'm going to do 2 hydrogens. I have 1 carbon here, right? No number next to carbon. So 1 times 2, I have 2 carbons. 1 carbon, 2 carbons. Again, it doesn't matter where you put them as long as they're connected. And then finally, I have oxygens. There are 3 oxygens inside the parentheses and a 2 outside. They multiply together. 2 times 3 gives me 6 oxygens. All right, so 1, 2, 3, 4, 5, 6. Again, I don't care how you connect them, but there need to be 6, 2 times 3 oxygens. 1, 2, 3, 4, 5, 6. Purple is my oxygens. 2 carbons, right? 2 times 1, yellow is carbon, same for hydrogen, and just 1 calcium. All right, that's the modeling part. Now let's move on to the calculating. For the calculating part, you're gonna need your periodic table. So calculating the gram molar mass, you're gonna need your periodic table, which you can find under your course documents, right? You can scroll down here, here are your course documents. Here's our periodic table that we can use, da, da, da. You also are going to need a calculator. So I'm gonna use the online calculator here so that you can all access the same one. So in my other tabs, I have the periodic table and my calculator available. Let's try these. All right, so I have the same formulas, right? I already did KBr up here. That meant that there was 1 K atom and 1 Br. But now we're gonna figure out how much this weighs. So to do that, here's where you can show your work, right? To do that, we have K and Br. First, I'm gonna count how many there are. There's 1 K and 1 Br. Now I'm going to multiply, right? We've counted how many atoms, so we're going to multiply this by the atomic mass on the periodic table. So I need the atomic mass for K and for Br. I'm going to zoom in up here so you can see that a little bit better. All right, so K, I find K on my periodic table. I'm going to zoom in. Here's K. It has a mass of 39.10, right? We're doing the number that's the decimal, not the number of protons. We're looking at the atomic mass. So K is 39.10, so times 39.10. And Br, we're going to multiply by its mass, atomic mass. Here's Br over here, 79.90. 79.90. And now I'm going to multiply these through. It's just multiplying by 1. So 39.10 and 79.90. The second part of this is that I'm adding up these things together. So now I take 39.10 plus 79.90 equals, I'm going to use my calculator, 39.10 plus 79.90, 79.90 equals 119. 119. Because I have 2 decimal places in each of these ones, I want 2 decimal places in my answer. So I'm going to give that as 0.00. Make sure that you keep those 2 decimal places in your answer. And the units for this, these are weird units. They are grams per mole. That means that every mole of this substance, remember mole, we're counting molecules here, there are 119.0 grams for every 1 mole of this. All right, that's KBr. Let's try another one. H2O. Here we have 2 different, oops, come back. Okay. The first thing we do is we say we have H's and O's, and now we count them. There are 2 H's and 1 O, right? 2 H's here in the formula, 2 H's, and there's no number next to O, so there's just one of those. Now that we've counted them, we multiply by the atomic mass in the periodic table. So H, the atomic mass of H, where is it? Here it is. H, the atomic mass is 1.01. 1.01. Oxygen, we find oxygen on the periodic table. Here it is. Its mass is 16. So I multiply by 16.00. And now I'm going to do that math. 2 times 1.01 is 2.02. 1 times 16 is 16.00. Okay, the last step is I add them up. 2.02 plus 16.00. 2.02 plus 16.00. I get 18.02. 18.02. Remember, keep those last 2 decimal places in there. My units are grams per mole. The units are the same for everything. Let's try 2 more examples. You can do this. All right, the formula now is KCN2. So I have K and C and N. Ooh, wait. Sorry, I did this one differently, right? We changed that one to Ca. Just kidding. CaCN2. All right, so when I'm counting these, I have 1 Ca. When I'm counting the C in the end, remember that 2 multiplies through. 2 times 1 gives me 2 carbons. 2 times 1 gives me 2 nitrogens. Now that I've counted them, right, just like you were counting before, I multiply by what their atomic masses are in the periodic table. So first I have Ca. Ca is here, 40.08. So I multiply by 40.08. Next one, carbon. Find carbon. Carbon is 12.01. 12.01. And finally, 2 times for nitrogen. Nitrogen is here. Nitrogen is 14.01. All right, I'm going to multiply these out. 1 times 40.08 stays the same. 2 times 12.01 is 24.02. I'm just doing it in my head. And 14.01, I get 28.02. All right, now that I've multiplied through, I need to add them all up. 40.08 plus 24.02 plus 28.02. All right, let's add them up. 40.08 plus 24.02, 4.02 plus 28.02, 28.02 equals 92.12, equals 92.12, and my units are the same, grams per mole. All right, one more slide to go, let's do it together. Okay, CaHCO3, 2. All right, so remember, the first step is always to write down what elements you have. I have carbon and hydrogen, calcium and hydrogen and carbon and oxygen, right? Write down what elements you have. The second step is to count them. There is 1 calcium because there's no little number next to calcium. For hydrogen, there's just 1 hydrogen, but I multiply by the 2, so there are 2 hydrogens. Carbon, there's just 1 times 2, so there's 2 carbons. Oxygen, there are 3. 3 times 2 gives me a total of 6 oxygens. All right. The next step, I multiply by the atomic mass. Calcium, 40.08. 40.08. Hydrogen is here, 1.01. 2 times 1.01. I multiply carbon. Carbon is 12.01. 12.01. And oxygen is here, 16.00 times 16.00. All right, now I'm going to multiply all of these ones out. That's my next step, and then add them up. 40.08, 2.02, 24.02, and 6 times 16. Whew. 6 times 16, I get 96. 96.00, right? Keep all those with 2 decimal places. All right, the next step is just to add them up. 40.08 plus 2.02 plus 24.02 plus 96.00. All right, let's do them in the calculator. 40.08 plus 2.02, 2.02 plus 24.02, 24.02 plus 96.00, plus 96.00, and I get 162.12. 162.12, and these are grams per mole. Grams per mole are your units for all of these ones. Hopefully this has helped you to be able to do your lab assignment. You have 5 different compounds to do that are very similar to these. You can do it 5 of those ones where you're dragging the dots. Don't forget to do your the key also over here. And then you're calculating the gram molar mass for those compounds. Good luck, folks. I'm here if you have questions. Thank you.